In terms of agriculture terminology, today's webinar will be called a bumper harvest. Because I think we are going to cross a 200 mark today. And from the registrations, we realized that this topic is really, very popular, and a lot of people are very interested in this. Uh, and so I think it gives me great pleasure to invite all of you to join this webinar on developing data-driven systems for crop monitoring and yield forecasting. In this series, we invite innovators, thought leaders, the public sector leaders, researchers, and World Bank's teams who are transforming agriculture and food system using innovations and digital technologies. So as I told you that this is the 80th edition, and we have a community of 10,000 people globally who tune into this series there. And we feel that this is a good platform for you to share what you are doing in this field, and then for us to then take these ideas to the World Bank programs and investments which we do all over the world globally. So just to give you a factoid in this area is that we have now 58 operations which are investing in data and digital agriculture innovations globally in 38 countries, and we have invested almost more than $1 billion in data and digital agriculture now, based on, and this has become more urgent after COVID and the recent food security crisis, where data and digital agriculture becomes very important. Today's topic is very important in that context, and I am very glad that many thought leaders whom I have not met for some time now, Dr. Mandafro, particularly from Ethiopia, from the Agriculture Transformation Institute, who leads the transformation agenda there. Sudhir Kumar Goyal from Maharashtra, India, who has led many transformation initiatives in India. I'm glad to see a lot of you there, and many other people whom we look forward to providing the leadership in this area. I will not spend a lot of time, just some ground rules, that previous sessions from these 80 webinars are also available on our website, and someone will put that announcement in the chat and also put it on the screen at some stage. Please keep your microphones on mute to prevent any background noise. There is going to be a Q&A session after the presentation. However, we would like you to start putting the questions in the chat box while the presentation is going on, or as soon as this presenter has finished. Please ask questions, and I would request the presenters to also keep on monitoring the chat box and also start a virtual Q&A while the session is going on. In the end, our team will collect key questions from the chat box, and we will then go to the chair and speakers at that stage. And so over to now the first presenter who will kick us off, Yaqub Mudassir Syed, who is the statistician in the FAO office. Yaqub is the focal point for agriculture statistics and open data within the office of Chief Statistician at FAO. And he has worked as Deputy Director General at the Central Statistic Agency and was the National Technical Manager for Famine Early Warning Systems Network in Ethiopia earlier. Yaqub, over to you.
Thank you very much, Ramesh. I think you all can hear me very well.
We can hear you.
Thanks for the organizers for giving me this opportunity to just make a very short remark on the importance of crop production forecast and how we see it from FAO's perspective. As you might expect, FAO considers the value of the crop production forecast with respect to its importance in reducing risks. Because timely crop production forecast will play a great role in reduction of risks associated with local or national food systems, which includes all those activities involving the production, processing, transport, and consumption of food. Having reliable and timely crop production forecasts help us to make timely decisions at different stages of the food systems. This risk reductions that I mentioned should contribute to improved outcomes in terms of better flows and access, and as well as on socioeconomic aspects that includes increased wealth, increased income, employment, and economic growth. Moreover, this reduction also plays an important role in terms of health and nutrition, like reduced diseases, morbidity, and mortality. We all are here experts, and we know that there are a number of existing approaches and models regarding the crop production forecast. The chosen scale in terms of space and time affects the interest of the actors in the food system. For example, field yield modeling will be able to improve management techniques and boost actual yields, while at the same time considering the number of crops selected for the forecast also really decides what type of policy needs that we are really working with. Therefore, in terms of space, field level, or the number of crops requires to be decided in terms of what type of decisions that we want to make. At FAO, for example, the EMIS project, the Agricultural Market Information System, decided to focus only on the 4 major crops: wheat, rice, and soybeans, because globally these crops are assumed to be very important. At the same time, when you produce some crop production forecasts, the scale determines, in terms of time, we need to define, like, do we want a long-term effects or a short-term one? For example, the AGM IP6 to improve agricultural models in light of the medium and long-term effects of the climate change and on yield crop yields, while GeoGlam monitors current year conditions and contributes to national crop production forecasts on a monthly basis. So as I said, the scale really determines the type of decisions that we make and which type of users are really interested in this type of scale. For example, the global scale crop production forecast is more interested to international agencies, multinational companies, and it helps us to make international treaties, protocols, global businesses. While the national level scale crop production forecast might be more interesting for food security and safety, strategic planning, trade policy, and national governments are the main users of such scale of crop production forecast. As I said earlier, there are a number of crop production approaches or models out there, but the issue is which one to use in our context. So the evaluation criteria should be based on the forecasting system capacity to induce changes in the relevant agents' behavior resulting from their perception of risk reduction. So, in general, the ideal properties of the good crop production forecast model should take into consideration the reliability, objectivity, consistency with scientific knowledge, adequacy to scales, minimum cost, simplicity, timeliness, and sensitivity to extreme events. So therefore, when we really decide to take which type of approach, type of models that we wanted to consider, we need to take into consideration the main points that I mentioned earlier. In general, currently there are 2 approaches, as we all agree. One is the statistical models, and the other is called what we call the process-based models. The statistical model is a simple regression models. They try to link the variable of interest, in particular the yield, to the predictors known for the current season. And the predictors are usually chosen from the meteorology and or the remote sensing domains. The statistical crop models are simple and entail low costs, but they have great limitations. This is the main limitation of these statistical models includes smallest prediction interval around the average, and they cannot be extrapolated in time or space. To resolve these limitations of the statistical models, now we are working on when we are using what we call the process-based models. They impressed mechanistics models by replacing the theoretical relations with empirical functions. There are a number of such models that differ by their level of approximation, the choice of process modeled, and the dataset retained. However, most models require information on 1, crop management, nutrient availability, water availability, energy received. And This time around, thanks for the availability of remote sensing products, most models make use of remote sensing information in their models. And most models perform crop yield assessments not on biomass production or of pasture land. Therefore, mainly they are focusing on crop, not pastures. Therefore, in the countries like Ethiopia, where livestock is very important, then we need to do something else for the pasture production forecasting. There are a number of ongoing evolution to improve the models and the crop production forecast globally. International initiatives are helping for the evolution of the crop yield models. Academia, public administration, and the private industry are working jointly to boost this thing, to boost like model integration, foster interaction, knowledge sharing, and model comparison. Again, great forces are undergoing to secure access to validated data sets. As we speak, for instance, more than 300 data sources for meteorological information are available alone. Now, this time around, the problem lies more in choosing which data source to use than how to access, because the data access of the data is becoming more easier than that used to be. Availability of new remote sensing products is also really very encouraging ongoing evolution, and which really contributes to improved crop production forecasts. Availability of innovative working environments are also really very much encouraging. The NOAA Data Alliance with Amazon Web Service, the Google CP, the Microsoft, and the OCC are some examples that can be mentioned in this regard. Then there is also a great interest to moving from forecasting potential yield to forecasting actual yield, integrating the aspects linked to weeds, pests, diseases, pollutions, or adaptation, and considering this what I call the extreme events, which will really improve the output of our crop production forecasts. The future crop yield modeling will entail multidisciplinary interinstitutional frameworks, modular open source code, and free access reference data sets. So whenever we really think of improving our crop production forecast, one important thing that we need to consider is the organizational aspect. If the science is there, the models are there, but without a good organizational infrastructure, we may not be able to get the required results. Because crop forecasting is a complex multidisciplinary exercise, and it requires competence in crop management, plant physiology, meteorology, soil science, remote sensing, IT, statistics, and others. It also requires adequate budget and human resources for hardware and software, data and model access. For example, I give you just a few examples at continental and national level. For instance, the Indian Manharpuri National Crop Forecasting Center, it has about 20 staff members, and it costs its budgets about $1.5 million annual for running at the reliable crop production forecast system in the organization. The European Mars Agri Forecast, about 23%, and more about $1.6 million annual budget. The national example, I mean, my colleague would be going to go into detail. The Morocco, the CNTJ in Morocco relies on the team of 23 staff members. Therefore, it is really needs a good investment. That's what I want to capitalize. However, we need to make a good note that costs are lower than agricultural surveys, but the modeling approach will rely on close collaboration with national space centers and research programs. Therefore, the traditional, I'm not saying that it is more expensive than the traditional surveys, but still, it really needs some collaboration. As anything, crop production forecast also has remaining challenges that we need to deal with. One is the effect of climate change, particularly the extent and rapidity of these changes. We need to really closely monitor that one to have a reliable crop production forecast. Real-time estimations of crops is also becoming a challenge because more significant, this challenge is more significant if crop optimal location, management techniques, or disease progress are moving at a greater speed. Double or triple season cropping has moved 100 kilometers to north in the last 15 years. model based on past observation will become less relevant because we need timely information. The effect of climate variability and extreme events on the output of the model is also a remaining challenge. Again, the role of the private sector in developing the model is also playing a little bit of a challenge. One, because the cost of profit maximization. The public sector will have to finance the development of corresponding to the applications at national level, while we know every national government has its own priority than the crop production forecast, and the private sector is likely to boost the research at the local level. These are still the remaining challenges. To sum up, my key message for this audience is crop production forecast is important to minimize risk in the food system. Various models, approaches, data are available for crop production forecast. Therefore, identification of the proper model in our context is very critical. And one important thing is building institutional capacity is something we need really to give a due attention. Crop production forecast, as I said earlier, is a multidisciplinary exercise. Therefore, we don't rely on the agronomists or the IT specialists or remote sensing experts. This is an interdisciplinary exercise which really needs better coordination and cooperation is very critical. I think this is what I have for this the key personal remark. For more information on the points I raised in my opening remark, I encourage you to look at the two guidance or publications that are now used at FAO. The first one is crop yield forecasting, methodological and institutional aspects. And the other one is recent practices and advances for MS crop yield forecasting at farm and parcel level, which I'm going to put the link for the documents in the chat box just immediately after I finish my remarks. I think this is what I have for today, and thank you very much for your patience. And once again, thank you for inviting me for this interesting webinar. Thank you.
Thanks a lot, Jacob, and thanks for kicking us off, laying down the context. This is a very growing field, and I think the crop forecasting, I have seen that if we have good crop forecasts, then it benefits not only just the farmers, but also everyone in the value chain. The insurance industry, the financial sector, all benefit considerably from good crop forecasts. And if people are able to do forward contracts for their produce with good crop forecast, they would be able to benefit significantly. So I don't want to belabor, but I would request, since we have crossed already 417 participants, I would request everyone to keep their mics muted. It's a very difficult task when we have so many people from all parts of the world joining. So I would request the virtual webinar etiquette in terms of muting your mics there. If it would have, I would very much appreciate that. I would now move to the next presenter, which I think is has a very exciting presentation. We have Riyad Balagi. He's the Director of Projects at the AA Initiative Foundation. Prior to this, he was the Head of Agronomy and Agriculture Machinery Department at the National Institute of Agronomic Research in Morocco, Head of the Regional Center for Agriculture Research in Meknes in Morocco, and also Head of Department of Environment Natural Resources at INRA Morocco, and Head of Agronomy and Plant Physiology Unit. Many distinguished positions in the Moroccan research and the agriculture ecosystem. He is leading the CGMS Morocco crop monitoring system since 2009, and he will present the Morocco experience. Riyad, over to you.
Thank you, Parmesh. Thank you, Jacob, for the introductory remarks. I'm very happy to be with you today. Hello, everyone. I belong to the AAA initiative. In brief, this initiative was launched during COP22 to support African countries adapt to climate change in the agriculture sector. Today, I will present you the Moroccan crop monitoring and forecasting system. Let me share my presentation.
Yeah, can you increase the volume of your thing, because it's a little bit coming lower at the lower end, if it's okay with you.
it is at its maximum. I don't know what the issue is.
Okay, go ahead then, please.
Okay, so as I said, I will present you today the Moroccan crop monitoring and forecasting system. So this system was the first, the building or the scientific foundation of the system started in the beginning of the 2005, something like that. And since then we developed the system. So, but first of all, let me share my presentation. Okay. Tell me if when you see it.
We can see it. Can you put it in the presentation mode, please?
Yes. Is it okay?
Yes, it's there. Go ahead.
So, as background and just to present you the context of the Moroccan agriculture. So, in Morocco, the agriculture sector plays a very important role in terms of food security and in the economy side. It contributes to the GDP about 20%, but depending on the seasons. And the cereal system is predominant as in most Mediterranean countries, and within the cereal system, bread wheat, soft wheat, and barley are the main crops over the agricultural lands. So the cereal production is highly variable from one season to another due to the high variability in climate. So the Moroccan climate is mostly semi-arid, and the average rainfall is about 340 millimeters per season. The season starts in September till the month of May of the following calendar year. With so as I said, the high within season and inter seasons variability. Both the total season rainfall and the distribution of the rainfall within the season are drivers of the cereal yields. But the cereal production in Morocco is still low, due of course to the climate, but not only, but also due to insufficient technology transfer, capacity building, climate information services, like the crop monitoring and forecasting systems, and fertilizers used and insured areas. So the cereal production is strongly influenced by rainfall, and this could be seen through these figures. You see here the correlation between the total season rainfall and grain yield of cereals, and you see that this relationship is very strong at national level. Of course, the figures differs at subnational level. It's not so strong, but just to give you an idea of the importance of rainfall in Morocco, and this can be captured also through NDVI or other remote sensed products, and you see the correlation is also very high. Since the correlation between rainfall and NDVI is high, then the correlation between NDVI and cereal is also high. So the crop monitoring and forecasting system of Morocco is not only belonging to one institution; it's a multi-institution property. The institutions that are property of the owner of the system are the National Institute for Agronomic Research, which started the development of the system, and then the Meteorological Administration of Morocco, the Hassan II Agronomy and Veterinary School, as well as the Ministry of Agriculture. So the The CGMS, which stands for Crop Growth Monitoring System, was originally named in reference of the European CGMS system, the well-known European system built at the Joint Research Center of the European Commission, GRC. So the GRC provided the initial support to our system during the initial development stage in 2010. But since then, our system has been further developed independently, and now it's something completely different from the European systems. And the system was developed in Morocco to manage drought, of course, which is the main issue that face the Moroccan agriculture, and to predict in advance cereal harvests. Of course, the system is tailored to the specific needs of Morocco, but it can be deployed elsewhere given some slight arrangement. The system has been developed thanks to some projects, various projects, in fact, from the European Union, from the French Development Agency, and the World Bank now with the funding coming from the South Korean cooperation. So it has as many systems worldwide. It has it uses many meteorological and vegetation information, and it has capabilities in terms of modeling. It uses statistical modeling as well as artificial intelligence, and provide with crop monitoring, with crop forecasting and automatic reporting, as I will show you further on. So the system has three main components. The first component is the database infrastructure. The database infrastructure is decentralized. Part is located at the Meteorological Administration, and the other part at the Ministry of Agriculture. So it's a decentralized system. It has at least 2 to 3 servers working at the same time, and all the data is sorry, what's happened? It was disrupted. All the data is gridded in a reference grid of about 4 by 4 kilometers square, and this data are then processed to provide season analysis and all the capabilities provided by the systems. And of course, we have a web viewer that allows to play with data and to display data and to process with all the analysis. So here is a figure of the web viewer. So there is 3 main tabs in this viewer. There is a mapping tab, which offers spatial statistics on meteorological and satellite parameters, allowing users to customize their analysis and accurately predict yields for specific crops. The second tab is the similarity analysis, which helps enhancing prediction by identifying past seasons with similar agroclimate conditions. And then the automatic reporting, which provides with reports sent to decision makers in all regions of Morocco. And so here is so it provides prediction at province and national level in the framework of a project with the biggest insurance company of Morocco. We tried to improve the accuracy of the forecast and to go to sub-provincial administrative level at very small scale. So we did an exercise. Just to overcome the issue of not having crop statistics at this very fine administrative level. We try to specialize the data coming from the provinces with some geostatistical procedures. But so in absolute terms, the results were satisfactory, but in relative terms, since the average yield in some regions of Morocco is very low, no more than 0.5 tons per hectare. So in terms of relative errors, it was not satisfactory. So we are still working on that issue, and there is a project at the Ministry of Agriculture to increase the precision of the crop statistics and to have sampling statistics at fine scale in Morocco. So the system not only provide crop monitoring for cereals, but also it has a component dedicated to rangelands. So just to give you an overview, so the rangelands in Morocco is 74% of the total area of the country. It's about 300,000 kilometers square. They boast a diverse array of vegetation characterized by the floristic richness, comprising more than 4,000 species and subspecies. So it's a very huge areas. These areas are generally dedicated to domestic grazing, but the degradation, unfortunately, has reached alarming levels due to climate change, mainly, but not only, but also to overgrazing. So as you see here, it's a study we conducted several years ago to assess the degradation of the rangelands, and so the result of the study showed that almost half of the rangeland areas are degraded in Morocco, which is alarming situation. And so that's why we decided to implement the CGMS system, which was originally dedicated only to cereals, but to rangelands also. And we were encouraged to do that, since there is a stronger relationship between NDVI collected from satellites and ground biomass. And so this is a study we conducted in 2018, showing that we can monitor rangeland biomass through remote sensing in Morocco. And so we implemented this capability in the crop monitoring and forecasting system of Morocco. And here is a map of the rangelands. So we mapped the rangeland of Morocco, and here on the left side of the slide, you can see the NDVI of the second decade of May of this year, and on the right side you see the difference between the long-term average, and you see that almost all the area is in red, meaning that we are in a deficit in terms of rainfall and biomass over rangeland. And here is an example of sorry, I don't know what's happening. It's deconnecting. And to finish, here is an example of crop reports, of rangeland reports we provide to decision makers on rangelands at the end of each season, to provide information that could be useful for developers and the farmers and all the community. So thank you very much.
Thanks a lot, Riyad, for sharing very rich experience of Morocco, and I think very appreciate your leadership of this agenda in Morocco for many years now, and it's very difficult to share all that experience in 15 minutes. You've done a great job there. But Riyad, now start looking at the chat questions. There are highly technical questions coming in your direction. People are asking about how accurate this is, what are the different approaches there, the units. So if you can start looking at the questions and responding to some of them, because we might not be able to take all of them at the end. So please start looking at the chat, Riyad. And if there are more questions to Riyad, please go ahead and put it to him. because we will try to take as many as we can towards the end. Thank you
I'll
very
do my
much.
best. I'll do
Thank
my
you.
best.
Thank you. Now, our next presenter is Kindi Tesfaye Fantai. He's a senior scientist with CIMMYT based in Ethiopia. And he has more than 15 years of experience in executing and managing climate crop modeling and GIS related projects for agriculture research and development in developing countries. During his time at CIMMYT, he has developed data acquisition systems, quality control for climate crop modeling and geospatial analysis. He has also developed a digital agroclimate advisory system that provides decision support to smallholder farmers. Over to you, Kindi.
Thank you very much, Parmesh, and this is great. Thank you all. Hi, everyone. I think we appreciate that we have a lot of interest today. First of all, I would like to thank the organizers for this excellent session to give us an opportunity to share what we've been doing, and if that works for others, it is a very good privilege for us to share our experience and also receive feedback from this great audience. So thank you so much. Thank you, the World Bank and others who organized this. So let me share my screen. This is collaborative work with our institutions and colleagues. And I'm happy to represent him here. Ato Sayas Lema from the ministry will also join. He's here and will present part of the slides that we have prepared here from the Ministry of Agriculture. Robel, he's the one who has been working with us, and he's joined here from CIMMYT. Baktang and Gerrit from the University of Florida are part of this work. Adi Sudabele again from the Ministry of Agriculture, and Traore Sibri from ICRISAT has been joining this work over the CCAF's era, and Dr. Daud Solomon from CCAF's earlier and now ECRA and ILRI. So it's a collaborative work. It is more from the national and international partners. And we are very glad to present. So our title is using the crop yield forecasting tool using the CCAF's regional agricultural forecasting tool, or in short, we'll call it crafts in Ethiopia. So we'll share that. Next slide, please. So I think the reason that we opted to work on this issue is that there are a lot of factors that affect crop yield. And crop yield forecasting is not that easy because there are a lot of factors involved in it. And many of institutions and actors are affected by, the climate variability and now the big issue of climate change. And most of the focus so far has been given to weather forecasts that has been developed over years. But in many ways, these weather forecasts are not converted into impact forecasts, mostly what we call them yield forecasts. And in fact, yield is one, and this is affected by a lot of trends, economic, political, and other issues, structural issues, and behavioral issues. And within a season, a lot of interactions that happens and that affects, what we call the impact or the end product of a given season in a given crop area. So next, please. So the missing link here is how do we, yeah, can you go back? I think that's the problem of not operating yourself. So the food production aspect is important because that has not been really addressed in many ways because most of the focus has been on the climate forecasts, and there was no such until recently the tools to do that. So our intervention here is to look into the food production shock, which is also part and process of the whole production system. And to do this, we were looking for tools that can be useful for this. There are several tools. In fact, one of the presentation focused on remote sensing. but also the other important factor is the statistical that was mentioned during the introduction part. And the other one is the crop models, which are very important in a way that they can represent, the whole systematic issue in there. So look, takes into account the different factors that are affecting crop production. So next, please. So in this case, therefore, we needed to focus on tools that integrate, different facets of information for meaningful analysis of seasonal and also intra-seasonal climate variability, and also delivery of early warning information and advisory, which are really required by policymakers, by those who are involved in advisories, in at local conditions or local governments, and even farmers. Next, please. So with this in mind, we opted to use this craft tool, which has been developed by the CCAF's program, and developed and tried in many areas, including in Asia and in Africa. And then we want to focus on here Ethiopia as pilots in Africa. So this tool has got many components in it. It has got as an engine the DSAT crop model system. DSAT is the engine behind, but this one has got other additional features in it to suit for yield forecasting at different scales, not only at plot level or at pixel level, but also aggregated at different administrative and national and regional levels. So to do that, it bases itself as a calibration of observed yields at different units or scales, and then detrending those yields to calibrate, yield, because in many areas, crop models do not take into account, plot level conditions, because they are limited, because they don't take into account factors such as pests and diseases. So to take that into account, this forecasting tool, we went off. Can you reshare again? Or let me share it from my side. Yeah. Yeah, I think I did it from my side, so you can interrupt yours. Can you see it now?
Needs to be on the presentation mode, Kindy.
Yes, I did it.
Now it's okay. Please go ahead.
Okay now? Yeah, very good. So yeah, in this case, it takes into account an observed yields, and these observed yields are used to calibrate yield levels of crop models, and these calibrated yields are then again feed into the yield forecast, which is coming from the crop models. And then the crop models also needs future climate data, which comes from climate predictors, such as the climate predictability tool from Climate and Society, Columbia University, developed by them. So that uses, that brings in, the future climate as a predictor. And then the crop models generate yield, and that yield is influenced by the forecasted climate. And then finally, you have a combination of calibrated yield adjusted to provide forecast yield. So the forecast yield in this case is a combination of detrended yield, outputs from process-based crop models, in this case DSAT, and then the future climate using the CPT tool, using predictors. And then finally, we have the forecast yield. So that forecast yield is now the one that we're going to talk about. So for Ethiopia, we focused on maize and wheat crops. And for this presentation, we focus only on maize because of the time limitation. So the first thing that we did was we have to build a database that is important to run the crop models, that is graded soil profile database, graded historical climate database starting from the 1985, and graded crop management data, and also local varieties that are calibrated for this purpose. So the area of maize is that you can see from this, it is almost growing all over Ethiopia, and the production varies, from as low as from the area, it varies from as low as 50 to greater than 1500 per unit of a pixel area. And then we used two popular varieties that to represent this production level. One is the long maturing crop variety, which is BH66, 61, and another one BH54 or BH456. Alternatively, to look into these growing areas. Some of them are high growing areas. Some of them are low growing areas, and then we apply those ones across those growing areas so that we can have a representation of the different growing areas in terms of crop maturity level. And then we looked into, again, with the Ministry of Agriculture collecting this information, the amount of fertilizer that is applied at different administrative units in Ethiopia. So that is collected by the Ministry of Agriculture and done for all maize growing units across the country. So the method of yield forecasting here is then depending on, as we said, is the engine is a DSAT model. The DSAT model initializes itself starting from, say, January 1, which is, we call it a spin-up simulation using historical data and available soil and management data. And then we set the forecast date for the future season. In this case, we use April 1st as a forecasting date for the June, July, August, and September season, which is our forecasting period. And then that combines, in this case, we use the sea surface temperatures as predictors using the CPT tool as a major one. And then that is used to generate the future climate. And then we generate forecast simulation from this one. And this, every time you can update it. The good thing of this system is that it allows you to run your simulation. You start it from 1 April, but if you have the May data as observed, you can run it at June 1. When June data is available, you can run it at July 1st. It goes on. So you can do it at any time, so long as you get observed data. So you can improve, the forecasts as you go along the season. So the results from this forecast, we use the 2021 season. We're presenting that. We did it after that, but I think we choose to present this one because that was our main detailed work that we did. So the first thing is to look yield of maize across years. You can see the observed yield was ranging from as low as 2 tons, goes to up to 4 tons. And then detrended yield is presented here together with the simulated yield. And you see that the detrended yield is very close to the calibrated yield. So detrending is important in that case. And that reduces our root mean square error, from 2 tons to less than 0.2 tons, which is very good. So that is why the craft tool is important in doing this. So far, there is no any other tool that allows you to do this. And then we calibrated our model and production across the country. So this becomes our base, which is a crop simulation after the calibration. So this is the distribution of maize all over the country. So this allows us to look into our existing knowledge and also past knowledge to look into how our simulations vary across the country. So this was a very good representative of what has been happening and what is reported. So then we continued once the calibration is done. And then we evaluated again. Once the calibration is done, we evaluated our model against reported yields from the Central Statistical Agency, now called Ethiopian Statistical Services, by administrative units. And we did that. And also we evaluated whether these administrative yields are acceptable or reflect what we know about the production system in those areas. So we did it for all maize growing regions. Then we looked at again the evaluation with the separate data, and we found that there is a reasonable correlation between the forecasted yield and the yield observed over years, and with acceptable root mean square error, which is very close to 1 ton per hectare. So, but I think this is there are so many uncertainties that are coming also from the measured yields, and also the simulated yields do not take into account biotic factors. So we accepted this as a very good correlation or representation of yield at a national scale. And then we forecasted the 2021 season using our model. And if you look at on the one, you can see it on the left side is the forecast for the 2021 season. And on the right, you see the standard deviation. So we can see that the model has represented both the spatial pattern that's observed during the evaluation, as well as the variability that happens in those districts. So we see that the model represents both the spatial distribution in terms of yield, as well as the variability that happens across those regions. Because those regions in Ethiopia, they have their own different agroecologies, and productions are so variable, not only in temporal, but also on spatial scale. And we found that the model has represented this in a reasonable way. And then we compared again our forecasts by administrative units. And as you can see that the 2021 season forecast was on the left side by administrative unit, and also the variability on the right side. This one is also very good in our assessment that the model has also represented this lower level administrative unit yield distributions that has been observed in the past and also represented in the 2021 season. So when we conclude, finally, what we did is the national average yield for forecast yield for 2021 was around 4.3 tons per hectare. And within that same year, after harvest is completed, the Ethiopian Statistical Agency reported an average yield of 4.1 ton per hectare. So which is almost the same as the forecast. And this is a very good indicator that, captured at least the national mean after harvest. So this is a very good thing. Something that we observed in this process is that the model slightly performs poorly in areas where year-to-year variation of maize yield very high. So capturing those annual yield variabilities in marginal maize areas seems to be something that we need to improve. Another one we learned from the process is that the crop, the model has shown, this very good agreement with what was observed. And this could be a very good tool that can be used for yield forecasting at different scales, not only at national level, but also at lower administrative units and even beyond national levels. We have presented this at different forums at the GACOF, and there is promise that this could be used as a regional forecasting tool for the IGAD region. But I think something that we learned from this process is that model performance is a result of data availability and data quality. So unless you work on the data that you have, whatever tool you have will not give you the results that you want. So our effort on trying to develop a huge data, soil data, management data, and weather data helped a lot in arriving at this kind of at least reasonably well results from this crop model. So I think that data is always important, and it is emphasized everywhere, but we witness that unless you have good quality data, unless you have very good detailed data, then you can't arrive at what you want. So that is all from my side. I think for the next 2-3 slides, Mr. Isaias from the Ministry of Agriculture will continue.
Before
Isaias, now you continue.
Isaias starts, can I introduce him? Because I could have introduced both of you
Yes,
together.
please. Yeah, yes,
So
please.
if you
Thank
don't
you.
mind, and then Isaias could take over after that.
Yes, yes,
So,
please. Go ahead.
it's my pleasure to invite Isaias Lamahai. He's the Director of Crop Development Directorate within the Ministry of Agriculture and Natural Resources in Ethiopia. He has extensive experience as an agronomist, extension professional at different levels of the agriculture sector across Ethiopia. Over to you, Isaias.
Thank you very much. Dr. Kende, can you put it to the slide? Okay, yes. Within the Dr. Kende presentation, and we have worked a lot of activities that support the Ministry of Agriculture, especially our forecast systems or evaluation systems are more or less late for decision making, especially for planning purpose. It is late, like the Central Statistics Agency, now the Central Statistics Service do this assessment, especially on September. The first report comes and the final report comes on March. So it will not help you for planning purpose. So this report will help for planning purpose, and the human interference also is very low when we look at from this model results. So this planning. The operational planning support for this report is which helps us for input supply, for distribution of inputs, like we know that the actual time and where to be, these things are essential. So it will help us this one, and mobilization of extension service also, capacity building and other services can be done through this in planning part. With that, it will also have a support in seasonal advisory using updated forecasts, like especially disaggregated crop performance we will get from this tool, location specific extension service support also. As you see that it is at second level, zonal level results can be get from this model, so we can know where to do this extension service, where to do any support activities can be done. The next one is it will also help to get production outlook, also one of the issues which we have to look. It will also help us for food supply estimation, that some of the reports come lately, and it will be helpful for early planning of these supplies also. And it also helps us for preparedness of early action also. Mostly it is governed by EDRMC, but most of the reports, especially the multi-sectoral assessments, are late. So this type of models will help us to do early preparedness activities. In the next, can you put in the next slide? Okay. Within this regard, through the project of SICAF supported, we have done it human capacity building, series of trainings provided to local institutions which are concerned with this one, especially the Ethiopia Meteorology Institute, who supplies the climate information, the Ministry of Agriculture, EDRMC, Ethiopian Institute of Agricultural Research, were capacitated with the craft tools and other crop modeling supplementary trainings were given. Establishment of a community of practice from this organization, about 20 people were trained with this tool. We have done it these 3 times, and we have a community of practice who can do this activity, especially when you do the management collection of data, organizing the data for the tool is one of the activities which are done by experts. So the community of practice do these things. Backup and technical support from CIMIT and University of Florida, which is still they are continuously working with this one. Strengthening data collection and quality control capacity, especially the CIMIT is supporting us in developing the different formats and sampling techniques to get especially the management, the crop management data which should be collected through the Ministry of Agriculture. Regarding to infrastructure, high performance computing facilities, especially which are supported by FPO, we get these computers, and we are using these computers which needs these models need high competing computers, and we are starting to use these types of computers. Integration of existing data servers is the next issues, which currently IGAD is working with in different like the drought watch, the geoglam. We are working with RSMD, like the crop monitoring reports are produced monthly through IGAD. So we are trying to integrate with this type of things, and we are working also with FAO, with agriculture and agricultural assist tools, which is agriculture and stress index system. We want to also integrate this system with these different systems also. And in addition to that, we want to use as a complementary for the multi-hazard report system, which we do yearly, 2 times in a year for main, short season and main season cropping time. Next slide. Okay, as a way forward from the which we have learned in the 2 years activities we have done, use of the tool as a crop forecast and decision support system for a major food security crops at the Ministry of Agriculture in EDRMC. EDRMC is
Please mute
one
your
of the
mics,
essential
please.
things we have learned, including additional crop. Dr. Kende mentioned maize and wheat. We did this competing for maize especially. We wanted to bring more crops, especially focusing on food security crops is one of the next steps. Collaborative improvement of the craft tools also essential, especially to get more data from partners as well as regional peoples who are working at ground level. Strengthening the national capacity through additional training and expanding the community of practice is also one of the essential things. I think many people are participating today. We hope you will join us this community of practice on improving the craft tools also, because it needs more data, it needs more competing activities also. As a last, strengthening the competing resource at MO is one of the issues. We need to integrate these things with the existing systems, and we need to get more supporters to have a better capability in producing such reports. I wanted to mention that we wanted to also integrate these things in GACOF, in IGAD, Great Horn of Africa Climate Forum on 16th, I think during the COVID time. We presented this also to integrate in IGAD countries also, and IGAD is working on in different crop monitoring tools. Drought monitoring watches are existing. Even Ethiopia is using these tools also. So we wanted to integrate with this one, and with RSMD also working on the crop monitoring reports, which are done with the University of Maryland. And one of our big partners is FAO. We have started with the PROACT project also to integrate this with this system, the agricultural index, stress index system. So this is one of the next steps to integrate this system with other tools, because if we use more tools to get a better forecast, I think our forecasting capability will be good to give the policymakers a good advice. With that, I would like to say thank you for all collaborating institutes which has supported in the last 4 years in doing this with this craft model. The Ethiopian Institute of Agriculture Research, they are working on IDACAP and other tools also. They are supporting very much. CIMIT as a coordinating, and they are also providing the whole scientists in doing these activities. The International Crop Research Institute for Semi-Arid, that ICRISAT also supported with the technical experts. I think I am looking Dr. Mazgab also in this, he's participating also, he's part of that. And the University of Florida, Professor Garrett and Dr. Vaktang and other teams of the DSAT community also participating. CCAF's funding these all things is one of our greatest partner. Now ICRA follows these programs. With that, I would like to say thank you for listening our presentation. Back to you, sir.
Thank you very much, Kendi and Isaias. I think giving us a rich flavor of what's happening in Ethiopia on this crafts and other tool, and its potential to go beyond Ethiopia and to go to other crops as well. So I think there are many questions for you, Kendi, as well. Please look at the chat and answer as many as you can before we bring them to the main. We will bring some of the questions to the main panel also at the end. And now it's my great pleasure to introduce my colleague Nagaraj Rao Harshdeep. He's a global lead for disruptive technology in our Sustainable Development Practice Group. He has, in 24 years at World Bank, he has led and supported several environment, water, and other natural resource operations and provided analytical support to a lot of projects of the World Bank. He has worked on watersheds, integrated basin planning management, environment, ecosystems, climate resilience, data access, modern Earth observation, and so. So over to you, Ash, for your remarks for next 5 minutes.
Great. Thanks a lot for this, Parmesh, and also thanks for making me younger. Now I think it's 27 years, but that's good. And also thanks for putting together this really amazing webinar with a lot of good insights on looking at this key issue of yield forecasting. Now, this has been something that's been on many people's minds in terms of how to do this not only at the retail level for a particular area or a country and so on, but also even to dream about how to do this globally, right? And that is where I think we can draw a lot on some of the other areas we work on, for example, in water, where also they're struggling with similar things when you're trying to forecast anything else, like you're trying to forecast a flow or inundation or things like that. The thing that's crucial is basically to have a good data set of what it is you're trying to forecast, right? So in this case, it looks like it's going to be a crop yield database. Now, there have been attempts to try and make these global crop yield databases very recently in these systems. But this is something that I think places like the bank, FAO, and others could work together on to help think of, that is the crucial missing piece now, which doesn't exist. Because the rest of it, in terms of the different mousetraps, we've heard from all the speakers, and I think Riyadh, Kindle, SAS all had great approaches to try and use either statistical approaches or process-based approaches in order to do this. And a lot of these could then be brought to bear if you knew what it is that actually happened in a particular location. So imagine for any country or even globally, a database of, for this particular area, this is the crop and this is the yield of the crop at this point in time where you're estimating it, right? So if you had a database like that, and these could be financed in terms of making it cheap by having foundations, a lot of these online foundations that we can pull together to make these go from a database to data services. Because one of the things that's changing a lot in the world is to go from these retail level desktop modeling type approaches to more cloud-based analytics that are, can be scaled up to any level, and then you can visualize the results by whatever you want, admin area, different scales, or basins, sub-basins, watersheds, whatever, or agroecological zones, or draw your own areas and so on. So post-processing you can do later, but the big missing thing is having a good public domain open service, which is accessible through open APIs of these kinds of what is the actual yield in these places. Then everybody will have a better mousetrap. Now today, with a lot of the AI, machine learning, deep learning type approaches, everyone can come up with amazing things just by throwing lots of data at it in terms of satellites and rainfall, a lot of the chirps data, other things that have been discussed in the thing, NDVI and so on. And a lot of these can get you some really good estimates of these things. But when you get a lot of these models, the big thing is you need to compare it with something to see with how good it's doing. And those usually tend to be at a very retail level. And this is something which, if we can slowly build a consortium to do in the more open public domain space, it could unleash a whole range of creativity in terms of making these also as free services that are accessible that people can bundle with other things later in terms of selling them as services, or being accessible not just to the really wealthy big farmers who can afford it, but the smallest shareholder farmer that exists anywhere can also benefit from this kind of insight, looking at not only weather information and other things that's currently packaged in agro advisories, but also yield estimates for their farm in those areas. And this is where I think we're at the beginnings of this journey, and it's great to see the examples both from Morocco and Ethiopia in this regard. The other thing is in terms of, I think from what I got from the speakers is a lot of these tools tend to bring people together. So we heard from, Riyadh about two ministries working together to try and then benefit from this. And this is something which I think you can make even bigger by making these public platforms for being able to visualize a lot of these services. And once they're services, you can have a million different platforms under each institution to visualize a lot of these types of things, and also spur a lot of these open development, once these things get out there. So, I mean, in summary, the big things we may want to think about in terms of going ahead are, one is how do you make these into open services that everybody can use? And this is where I focus on the big crucial thing, which is data service of what is the actual yield for different crops. Start with these four that we were talking about. The rice, wheat, maize, soybean seems to be the popular one. But in Africa, there's many other crops that are important. So pick a few different crops where you can make slightly more global accessible databases that other people can use as data services. Then to also see if you can help leverage a range of these cloud analytics to then show in the form of different dashboards. Because we heard from the speaker on the FAO system from Elias and others, SAS and others, you really shouldn't need good computers to go do any of this analysis. It should all be in the cloud somewhere, and you should be able to do really powerful analytics from your phone, right, today. So that's the kind of thing which we need to move towards in terms of leveraging a lot of these new technologies that are there. And there are lots of great examples of this already happening with, for example, I don't know if you've seen, I can paste later, the bank geospatial platform at maps.worldbank.org or FAO's earthmap.org, which is an amazing site where you can do a lot of these cloud analytics. Imagine why you can't have crop yield as one of the other things that's displayed there, in addition to all of the different services that are there, and to automate this entire process so anybody can then use the results for their use and repurpose it and repackage it in their own way. And then you can get the actual argument about which tools are better and thing based on actual data, which people can then compare different tools. But also with this and with the multiplicity of dashboards that will be created, it'll be good to do a lot of capacity building events. So things like this, which Parmesh and others have been organizing, if you can have ways in which this can become a regular affair, just on this particular topic as well, where you can see what's the latest on this. Is there any other new mousetrap, new ways of analyzing that people have put together, learning from each other, trying to see how a public platform has been created for these, because then it's something that will produce scalable data at the country level or regional level or a small watershed someplace or other things, or even at the farm level, to be able to do this because of the scale of the data we currently have. Because the current global data sets are 0.5 degree, which is like 50 kilometers by 50 kilometers. So that's okay for doing some things, but it'll be good to try and see if you can make it even more high resolution, given that a lot of the input data is now getting finer and finer resolution, whether it be versions of chirps or versions of a lot of these satellite data sets that are there in the public domain. So anyway, thanks a lot for this invitation, and I think it's something which could be the beginnings we see of a great free, open, public domain global system for for different crops for yield estimation that could completely revolutionize a lot of the work that we are all doing in the world across. Thanks again, Parmesh, for the invite.
Thanks a lot, Harsh. And then I'll now, we are running a little bit behind time. So Mary Agnes, I would like you to be brief in your remarks, because I would like to bring some audience questions also to the panelists at the end. Go ahead, Mary Agnes. Mary Agnes is agriculture economist in the data-driven digital agriculture innovation team and has vast experience working with earlier with OECD and lots of other institutions on these kinds of approaches. Go ahead, Mariam.
Thank you very much, Parmesh. Listen, I'm not going to be long because I think Harsh said so many things, and I really want to thank all the panelists, because basically what's happening here is that we're learning from you. And what we're learning is that all this business is not easy and not straightforward. And this is what in our team we've been trying to look into, how do we make it easier for everyone to be able to produce these kind of data and to be able to use them and put them to use. And I think we've heard, some examples here. We want to learn more from you. But some elements that we've been thinking about, and maybe we could talk about with you about how we could proceed to help our client countries really, learn from all this and go faster and leapfrog into not only the creation of these data platforms, but also putting them to use, as we've heard with Morocco on insurance, but also in Ethiopia with all the range of elements that have been showcased on how these could be used, not only for data-driven decision-making, but also for the private sector to develop services to farmers. So there's really some elements just wanted to focus on. First, we're actually strong believers in the new capacity of new types of data with Earth observation. And we've recently had on the 24th of May, an international workshop on this, focusing on food security, but we know that there are these foundational databases, crop yields forecasting being one of them, that can really help on so many other issues. And we're looking forward to developing these partnerships. So how maybe we can, as Harsh was saying, making this more easily available to many more countries. The other elements, I think, and that's linked with the global public good, is that it's not only about data. We see that there's all these modeling that has to be done. We need to make it easier to do all this processing, and we need to make it easier to have the partners that can help with this. And yet again, why each and every time have to reproduce these kind of MOUs maybe that have to be produced for the sharing of data, or for ensuring that different partners come together, including the private sector actually. And in the case of maybe better fertilizer use, we're collaborating with some partners like Planet, which is a private sector data provider. But do we need to waste time every time to make new contracts? So we have many ways that we can make it easier. And so, some roles for the World Bank is to make it easier for you. So we need to learn more about what kind of data you also need. But also it's about how we make it more easier to put it to use. And I think on this, it's again, partnership. It's again, getting maybe the research out of its comfort zone sometimes. And, the way we have to communicate with some of our partners, we don't necessarily always need a perfect product. In research, we always want to be sure when we provide some advice. And one of the work when you go out of research and maybe more into policy making is that you need to extract and be fine with, maybe sometimes it's second best. So how do we communicate this and bring these people together, showcase that we can maybe not be 100% better, but 50% is already so much better in some areas. So how do we bring these communities together, but also better communicate about what can be done? And we've had so many great examples today about everything that could be done based on this kind of data. So maybe our role as the World Bank is to, go with you and meet other people and bring these stories together out in the open about what we can do with this great data, because this is an invisible infrastructure that we're asking countries to invest into. And so it's a lot to demand. It's a lot of money that's usually behind this. So let's maybe showcase better how this can really be changed, maybe some fixes, that we can do to make this more straightforward. I think that's all I really wanted to say today. Leave time for conversation as there were so many questions, but thanks a lot for bringing me here today. Very interesting presentations. Thanks.
Very much, Mary Agnes. So I think what we'll do is we'll go for one round of questions with the panel, and we would like everyone to respond to some of the key questions which are more strategic at the end. I think I really appreciate all of you, Riyadh and Kendi and Asai, all for answering questions during the chat. I want to announce to the audience that all the proceedings, which includes the recording, the presentations, and also the chat script, which includes a lot of Q&A, we have made that now a part of the proceedings, because there's so much rich discussion which happens in the chat, and some people said Are we going to lose it? No. I think you're going to get all the Q&A responses in the chat as part of the proceedings as well. This is the new way of documenting in the new virtual webinar world, where very rich discussion happens in the chat while the discussions are going on. So I would now pose questions to different people in the audience. Riyad, the first question for you is, how do we achieve sufficient reliability and rigor in the forecasts, but also balance this with technical feasibility and available resources to produce forecasts frequently?
The issue of the accuracy is not an easy. There is no any easy response to that. It depends on the accuracy of the data you have as input. The modeling is not so important. The most important part is to have the most accurate data to analyze. That's the main issue, and that's what we found in our own experience. So now, with the new satellites and information available on the net, this kind of information is not critical. But the most critical information is on crops, is on the crop statistics, the data you collect from the fields, and the spatialization or the details over a region you could collect. That's the main issue. The other components of the systems worldwide, whatever it is, US system, FAO system, or whatever, or European system, they are almost the same, relying on regression analysis, crop modeling, random forest analysis, and whatever, but they achieve almost the same accuracy given the same data as input. But the difference between the systems are the data used to produce yield forecasts. From my point of view, is that. Now, on the other hand, the methodology used depends strongly on your situation, on your particular. If you have some global systems, you need global data, and maybe you need less processing, less modeling. Let's say less modeling. And sometimes at the level of a country like Morocco, you don't need sophisticated approaches. We tried a lot of models, the European model, WOFOS, the FAO model, Aquacrop, and others, and others. What we found is that the added value of these models is not interesting, unless you want to forecast at the farm level. That's another story. But for a food security perspective, for national perspective, the simpler is the best, and the simpler is the statistical analysis, and now the random forest if you have a lot of data. So that's a short response to the question.
Thanks a lot, Riyad, for really explaining the whole perspective of what is, what makes these things more reliable as we go forward there. Kendi, over to you now. You could take the same question, but there's another question I want to ask you is, what is your experience with institutionalizing and having continued financing and resources for this forecasting? Does this require resources all the time, or initially the resources are higher and then the resources could be maintained at a certain level? And what has been your experience in Ethiopia of getting access to these resources?
Thank you very much. And also thank you very much for all of you. I'm trying to respond to some of the questions. A lot of interest and a lot of compliments and some clarifications. Thank you very much. Yeah, from your question, as the previous speaker said, the most important part for what we do is data. Yes, we have nowadays tools. We are now migrating to AI. and also several things, but all of them without data, you can't do anything. So everything that we have is as good as the data we have. And we need to give emphasis in the collection, archiving, and quality control of data. That is important. Now the tools are available for us, but also we need to be careful in some way. Some of the things I see is that tools, cannot make you better. You make the tools better. You are the one who are playing with the tools. It's not the tools that makes you better. It is you who makes the tools better. And to do that, you need data, and always you need to have good quality data. So that is important. So I think people are comparing, this method and that method. Well, all the methods have their own pros and cons, but I think what makes them good is the data. So let's focus on data. Everybody, I think here understands that data is really a resource, and it is important for everybody. The institutionalization issue you mentioned and sustainability, this is important. In fact, we didn't do this alone. We knew from the beginning that ourselves, from the CG centers and also other from the universities, we can do it. But unless and otherwise somebody is using it, applying it, and also, mainstream it in their own functions, then this wouldn't be useful. So that's why from the beginning, we started with the ministry, and we have also technical people at the ministry already doing this in parallel with us. And building the data itself, not only running the tool, but also building the input data, how the data is collected, how that is made available, and how that is quality controlled. So we did that, and we hope that we'll continue with that spirit. But I think the role of additional funding is undeniable, because there are a lot of things that we need to improve. We have to go to more crops. We have to go collect a lot of data. We have to go for, going beyond Ethiopia and Africa. So in that case, we need more collaboration, more networking, working together, even improving the tools together. So in that case, I think both the practitioners, the institutions who are using it, who are applying it, and also who are improving it, we need to work together. And also here, those who have the resources also can chip in and help us to do that. So for us, our vision is to make these tools not only for a country level, but also this regional level forecast. This is climate forecasting alone is not enough. It has to be converted into impact forecasting. And to do that, these tools are available. So we expect everybody to chip in, from the donation up to collecting the data, making data open access available, and all that has to be done. In terms of the Ministry of Agriculture, I think we are also the Ethiopian Institute of Ethiopian Agricultural Transformation Institute is also there. So they have got a lot of data. They have got also a lot of digital tools. We are working with them. We'll continue this to be mainstreamed as part of the digital advisory roadmap. So that is one area. So this will be part and parcel of that, and we'll work together. So we'll have more of internal, collaboration and system of working together. So we'll continue with that. But still, we need also support from whoever is interested in those areas and make it available to smallholder farmers who are actually the final beneficiaries. So if you allow me maybe to respond to some of the questions, do I have a few minutes to do that?
Kendi, we are running short of time right now, unfortunately.
Okay.
We would like to close in time.
I have to respond for everyone here. There's a lot of questions,
but
I think
if there is one and you would like to take, which is more important out of that, please go ahead, and then we'll come to Jacob also, because I want to bring Jacob into the discussion.
Sure. Yeah, people asked about the lead time. How is the lead time? I think the lead time we use is the seasonal scale. So for Ethiopia and here, lead time of 3 to 4 months is okay. So we can use that one. But you can update every time. Every month you can run the system and shorten the lead time so that you can improve your effort. The other is the data quality and how it is compared with observed data. For the Ethiopia case, we solely depend on the Central Statistical Agency data that is based on crop cuts, and that is available at administrative unit. There is no any other data which is covering the whole country and available. So we want to be straightforward and comparable, so that we use the CSA data at administrative level unit, and that is the data that is actually used for calibration and as well as for validation purpose over years. So that's why another question is whether this model takes into account pests and diseases. It takes pests and diseases into account indirectly. Indirectly means that we are calibrating the model predicted yield using the observed yield, detrended yield. That means the output of the model is adjusted to the actual yield reported, which includes pests and diseases. So that is why we use this calibration with observed data. So the final output definitely takes into account these pests and diseases, even other factors. The other issue was about how this coefficient and things like that. I think we'll do that. That comes from the detrended calibration. So we'll do that. But the other thing is that we are also now working with excellence in agronomy that is helping us to improve crop management. That is one of the lacking issues. So excellence in agronomy is now helping us to develop and document those crop management data, and we are developing with them national data hubs, and that will improve in the future. So I think those are the things, but for others, I will make the responses on the chat. Probably, I think most of the questions I see that Craft is freely available, and it is downloadable from the DSAT Foundation website. So those of you who are interested, you can freely download it from the DSAT Foundation website. I have put it in the chat there, so you can do that. Thank you very much, Ramesh. Really appreciate it.
And thanks a lot, Kindi. This is a very important topic, and I think I would just like to announce at the outset that this looks like a community of practice which needs to be invested in for future, because the numbers I see now, first time reaching 444, and we still have more than 300 people still staying after, gives an indication of the interest of the people in the topic. And a lot of PhD students also writing in the chat, they're available and they're working on crop modeling, forecasting, and all. So I think we have to really build on this, and I will talk about some things we will do, how to follow up on this. But I want to bring Jakob to take one question, is with the FAO's institutional perspective as well. How can we strengthen the collaboration between individual, national, as well as the global programs? It seems we could benefit from shared resources and data and create a kind of a common data platform, the thing which Harsh was also talking about. Do you have any ideas on what FAO is trying to do in this area?
Yeah, thank you very much. I mean, this is very important. You know, this type of exercise, as you have been saying, and as Kindi was emphasizing, it's a multidisciplinary thing. It requires really a great cooperation, not only along national counterparts, but at international level, the private sector, the academia, and so forth. One of the areas that we need to collaborate is, sharing of data, because data is a critical thing at this point in time. Everybody was emphasizing data. The more ground truth data that we have, the more we can really improve our models. So that's a very important thing. Therefore, the data sharing exercise, moving towards this open data direction, is something really critical if you really are serious on this business. So in this regard, what FAO is doing is, to help member countries, as well as any data collected by FAO or by FAO or sponsored by FAO to openly available. So this for this we have built what we call the Food and Agricultural Microdata Catalog, whereby you can find farm level data or household level data, anonymized, of course, and with all the necessary metadata associated with this microdata. Therefore, it's not only, as I said, we are helping countries to be more open. At the same time, we are really trying to make this farm catalog as one-stop shopping center for any microdata related to food and agriculture. So this is where the IFU's direction is in terms of opening up, microdata to be more usable and used for decision making, including improving models like that of the crop forecasting model. Thanks.
Thanks a lot, Jacob. I think we have come to the end of a very interesting 90 minutes open sharing of ideas around this important topic. Clearly, from the number of people who registered and number of people who participated, there's a term which we call is a strike rate. The strike rate of this webinar is the highest we have seen in the real past. So it means this is something which people want. And I'm just assuring you that we will follow up with all the people who participated in this webinar to continue with this community of practice. And I'm inviting all the people who attended, if you have any other experiences to share, to please write to us. And we will put an email address in the chat. Please write to us and we will make it a regular series so that it's not one-off. And we are just discussing that. So if you have other examples there, a lot of colleagues from Latin America writing that is something similar as craft available in Latin America. So clearly there is across regions the need for the crop modeling and crop forecasting services, platforms, capacity, expertise. We have a big new investment coming in Ethiopia, and we are, as Kendi said, that there is a roadmap there, which includes, we had Dr. Mandefro here for quite significant time in this webinar, which shows the kind of commitment of the leadership in Ethiopia to really doing this. And I think clearly as World Bank, we are very committed to working with all the institutions and others to really create a platform which is kind of sustainable and continuous. As Kendi rightly said, that you have to have good quality ground data all the time being collected. And I think that also we need to investment, whether it's the weather stations, whether it's the other kinds of tools. But I think we need to combine this with other modern tools which are coming up. And I think if we triangulate all the methods together, then the rigor will improve considerably. And as we said, that the new people who come into it should be able to use that data platform rather than start from scratch. So we want this to become a kind of a more plug and play kind of a platform, where people are working on bringing new methods, new tools, and bringing and improve the forecast there. So I think clearly currently USDA has a very interesting forecasting method, and they really produce these forecasts which are not only used by farmers but are used by private sector, commodity traders, financials, and others and all. So I think there is a clear monetization case for investing in crop forecasting also as we go forward, because we ultimately need more investments to come into this sector. We need better services to farmers to develop that based on forecast, so that the next planning for inputs and services is better, as I really explained to us very well, at how you are using that data to plan for the next cropping season. So I clearly see the investment in platforms, investment in tools, investment in data rigor, investment in capacity to be made on a sustained basis. And if we could build a kind of a case for every agriculture and food investment, at least for the World Bank side, we should invest a significant type of our investment into this kind of a thing in every program there. And we are investing through CGI also a new program which you know about, which we are trying to work across Africa on that side. So big thank you to all of you for staying so long. And it's very late night in many places. It's late evening in other places. And so we really look forward to continuing this collaboration. All the people who registered for this webinar and who participated will get the proceedings, including the chat proceedings, the recordings, and other things. If you want to also access all the future webinars, you are now included in our network and distribution list. And these are some of the kind of links which we want to show you. But as soon as you registered for this webinar, you are now part of our knowledge network now. And you will receive invitations for all future webinars automatically there. And so I want to thank all the presenters, Jacob, Riyadh, Kendi, and SI, and Harsh and Mary Agnes for really making very significant contributions. And good night, good evening, good afternoon, where you are. Thank you very much.
Thank you very much.
Thank you very
Bye-bye.
much. Thanks a lot.
Thank you, Shah.
Thank you.
Thank you very much.
Thank you very much.
Thank you.
Thank you.
Very
Bye,
much.
everyone.
Thank you.
Bye.
Thank you.
Bye.
Thank you. Bye.
Bye.
Thank you very much. Goodbye.